Hi students, welcome back. We are in chapter Is matter around us pure? Question mark. You see the title of this chapter? It is asking us a question. Is matter around us pure? If you remember our last chapter, what we have discussed? Everything around us is made of matter, isn't it? But now our duty is to learn whether that matter is pure or impure. That is the concept we need to understand in this chapter. In previous chapter, we have learnt physical nature of particles. In this chapter, we are going to learn chemical nature of particles. So, in this chapter, mainly we are going to concentrate about pure and impure substances. You see, matter, which already we have learnt in our previous chapter, anything which has mass and occupies space is called matter. There are 6 types of matter, but in your 9th class we are going to learn only 3 types. Those are solids, liquids and gases. Now, matter are 2 types actually. First one is pure substance, second one is impure substance. By this what we can conclude? We can conclude whatever is there around us is matter, but all matter is not pure. There are pure substances, at the same time we have impure substances. Now we need to distinguish between what is meant by pure substance and why we are calling it as pure substance. What is meant by impure substance, why we need to call it as impure substance. What is the difference between pure and impure substances? That is what we need to learn in this chapter. Let us see this small flow chart. Matter. We know matter is made up of particles. Now, matter is divided into 2 types. First one is pure substance, second one is impure substance. Let us understand what is pure, what is impure by looking its definition. At the same time, let us take a lot of examples such that you can understand. Again, you can observe pure substances are divided into elements and compounds. We will see what is meant by element, what is meant by compound with the help of definitions and examples. And you can observe here, impure substances are also known as mixtures. And there are again 2 types of mixtures are present, which we are going to learn in our next session. First one is homogeneous mixture, second one is heterogeneous mixture. Okay, let us try to understand what is meant by pure and why we need to call it as pure substance. You can observe the definition here. Pure substances defined as materials which contain only one kind of atoms or molecules. So, if you want to judge it, if you want to say it as pure substance, that material should contain only one kind of atom or molecule. For example, let us take iron rod. If you take iron rod, consider this is the length of iron rod. Now you take this part. You take this part. Here you can observe iron particles. Now try to observe this part. Here also you can find iron particles. Now you can see this part. Here also we get only iron particles. This part, this part, this part. Whatever part you take, you will find only iron atoms, iron elements, isn't it? So this complete rod is made up of only iron atoms. So you can observe material which contains only one kind of atom. So this iron rod contains only one kind of atoms, that is iron atoms. Hence we can say this iron rod is pure substance. You can consider another example. Let us consider water. What is the chemical formula of water? It is, yes, it is H2O. H2O, chemical formula of water. Take one glass and pour some amount of water in it. Now, whatever part you want, you can consider in this water. You can consider this part, you can consider this part, this and this. Whatever part you consider, if you observe its color, smell, taste, texture, etc., everything will be same. And this part, what is the chemical formula of water here? It is H2O. And if you see, this part is also made up of H2O molecules only. This part is made up of H2O molecules, this part and this part. Whatever part you take, it is made up of H2O molecules. Hence we can consider this water as pure substance. That is the meaning of this definition. So, material which contains only one kind of atoms or molecules. Now you may get doubt. What is the difference between atom and molecule, element? Here we have four words: atom, molecule, element, compound. Four definitions are there. And don't consider that everything is same. All four are different. Let us try to understand what is atom, element, compound, etc. First, let us define atom. Atom is a smallest particle. Atom is smallest particle which cannot be divided into further. And examples, you can take hydrogen atom, which is mentioned with letter H, oxygen atom, O, iron atom, Fe, zinc atom, Zn, magnesium atom, Mg, sodium atom, Na, calcium atom, Ca, etc. These all are atoms. Next we have another definition and another term called element. Now most of the students will be confusing regarding this atom and element, and they think both are same. No, both are not same, both are different. What is meant by element? Element is nothing but group of similar or identical atoms. So try to understand the definition. Group of similar or identical atoms. Let us consider one example. Let us take hydrogen. If I mention H, that is hydrogen atom. Now add another similar, same or identical atom, that is hydrogen only. Hydrogen plus hydrogen gives rise to H2. Now if you see only H, you can consider it as atom. This is single H, you can consider it as atom. Atom plus atom gives rise to element. I think so you got now what is meant by element. If you take any group of same elements or identical elements, and we'll get elements here. So same atoms you need to consider, we'll get elements. Another example, oxygen O plus oxygen O plus oxygen O. Three oxygens combining together to form O3, that is ozone. Ozone layer is there, that ozone. Now oxygen is atom, this is atom, this is atom. Now here I told you group of. Group of in the sense there may be two or more. So you can have definition like this also. Two or more same atoms, two or more similar atoms, or group of two or more similar identical atoms. Atom plus atom plus atom gives rise to oxygen element. That is the actual meaning of element, and both atom and element both are different. Moving to another, molecule. What is the actual definition of molecule? Molecule is nothing but group of different atoms known as molecule. Example, if you consider sodium plus sodium, here sodium is one atom, this sodium is same identical atom. If it is identical, we have to consider it as element, right? Na plus Na is Na2 or 2Na, like this also you can write. This is an element. But if you want molecule, as I told you, it is group of different atoms. For example, you take Na plus add chlorine to it. Sodium is different, chlorine is different, gives rise to NaCl, that is sodium chloride, that is molecule. Now if I mention few examples, now you need to identify what are those. O2, H2O, MgCl2, N, Fe2, ZnO, Ca, right. Now you need to identify which one is atom, which one is element, which one is molecule. It is easy to identify. I told you, if you find any single letter, single symbol, it is atom. Element in the sense it is group of similar atoms. Molecule, group of different atoms. Now you see this O2. O2 in the sense it is O plus O, group of similar atoms, so it is an element. H2O, here we have hydrogen, here we have oxygen, both are different. Group of different atoms known as molecule. Here Mg is different, chlorine is different. So both combining together to form again molecule. Now you find only N. N is single. Nitrogen is an atom. Fe2. Fe2 in the sense it is Fe plus Fe. You can consider this one as an element because it is group of similar atoms. ZnO. Zn, zinc is different, oxygen is different. Zinc is metal, oxygen is gas. Both are different atoms combining together, so it is a molecule. Now Ca we have. Ca stands for calcium and there is no number, nothing, so we can consider this one as an atom. Like that you need to consider, and we need to differentiate between atom, element and molecule. And last we have another definition for another word, that is compound. Here we should not get confused because compound is nothing but group of elements or group of molecules. We know what is element and we know what is molecule, and how come this group of elements and group of molecules? You see, let us take an example. Oxygen plus oxygen gives rise to O2. Now what is O? This is atom. What is this O? That is atom. What is this O2? That is an element. That is clear. Now, if I take O2 plus O2, now you see, what is that O2? O2 is an element and this O2 is also an element. If element and element are combining together, then we will get, how many O2s are there? 2 O2 elements. So 2 O2, this one is known as compound. Now did you get it? Element plus element is compound. Let us take another example. Let us take NaCl, sodium chloride, plus NaCl, sodium chloride, gives rise to. How many sodium chlorides are there? 2. So what we can mention? 2 NaCl. Now, first NaCl is molecule. Why it is molecule? Because it is a combination of different atoms. This NaCl is also molecule because it is also combination of 2 different atoms. Now molecule plus molecule gives rise to compound. Now how many sodium chlorides we are taking? 2, means it is a group only, right? So it is compound. Like that, element plus element is a compound, molecule plus molecule is also compound. Now let us again see few examples for atom, elements, compounds, etc. Now if you write O, this is, yeah, it is atom. If I write O2, now this is element because 2 oxygens. Now if I write 2O2, this is, yes, not molecule, it is compound. Right? Now NaCl is molecule. If I write 4NaCl, Now it is compound. So I think it is clear difference between atom, element, molecule and compound. Moving to concepts. Now let us see what is meant by element and what is meant by compounds. Pure substance which are made up of only one kind of atoms. I told you earlier, oxygen plus oxygen gives rise to O2. It is made up of only one kind of atoms, that is known as elements. And these are one property you can observe, they cannot be split up into two or more simpler substances by any chemical methods. Here we cannot separate O2 by means of chemical methods. That is the thing. And best examples you can take iron, you can take gold, silver, carbon, oxygen, nitrogen, sodium, etc. These are all examples of elements. Again, elements are further divided into three categories. First one, metals. Second, non-metals. Third, metalloids. In 8th class, we have learned what is metal, what is meant by non-metal and what is meant by metalloid. Once again, let us try to understand all its properties. Metals. What are the properties of metals? Metals are lustrous. Every metal will shine. So that only we will use those metals in jewelry. They conduct heat and electricity. All metals are good conductors of heat and electricity. All metals are malleable and ductile. Malleable in the sense we can make it into sheets, ductile in the sense we can make it into wires. They are sonorous. Sonorous means which can produce sound. Metals are hard. Maximum all metals are hard except a few, that is sodium, potassium, lithium, etc. And all metals are solid at room temperature. We have one exception, that is mercury. Mercury is liquid at room temperature. Those are properties of metals. Next, properties of non-metals. Those are quite opposite to metals. Non-metals will have dull appearance. There will no shining. Non-metals are poor conductors of heat and electricity, but there is some exceptions. Diamond, which is good conductor of heat, at the same time graphite, which is good conductor of electricity. Non-metals neither malleable nor ductile. We cannot make it into sheets, we cannot make it into wires because those are soft. Generally, non-metals are soft except diamond, which is hardest natural substance ever known. And non-metals will be in form of solids, can be in form of liquids and gases at room temperature. But while coming to metals, 99.9% metals are solids except mercury. And while coming to non-metals, you can find in solid state, liquid state, at the same time gaseous state too. And we have another word, that is metalloid. What is meant by metalloid? The elements which have properties intermediate between those of metals and non-metals. Simply to say, metalloids will have properties of metals at the same time non-metals. Metalloids will acquire properties of metals and non-metals both. Then we have compounds. Already we have discussed what is compound. Compound is formed by combining two or more elements or molecules by definite ratio of the mass. What is the meaning of the definite ratio by mass? Let us consider H2O. What is H2O? It is water molecule. Now, if you observe that H2O, we have two hydrogens and one oxygen. Because it is H2O, we can say two hydrogens and one oxygen, and water is formed by ratio 2:1. Well, coming to sodium chloride, how many sodiums? 1. How many chlorines? 1. Ratio 1:1. Magnesium chloride, MgCl2, how many magnesiums? 1. How many chlorines? 2. What is the ratio? 1:2. That is known as compound. Here you can say examples: water H2O, oxygen O2, nitrogen dioxide NO2, etc. So till now we have discussed matter and what is meant by pure substance. Pure substance is divided into elements and compounds, and we have seen definition for element, we have seen definition for compounds. Again, elements are divided into metals, non-metals and metalloids. Next, we are coming to impure substance. Impure substance may be defined as materials which contain different kind of atoms. Simply to say, let us take salt and let us take sugar. Salt is different, sugar is different, tastes are different, chemical formulas are different, and if you mix together, we will get mixture. We can say it is salt and sugar mixture. And you take another example, water, and add glucose powder. Here water is different, glucose is different, its color different, glucose color is different, chemical formula of water is different, chemical formula of glucose is different. But if you are mixing together, we can call it as mixture. So what is meant by mixture? Mixture is material contains two or more different kinds of particles. We can say different atoms or different molecules. Here we are considering two molecules, salt molecules and sugar molecules, water molecules and glucose molecules. If two different molecules are combining together, we can call it as mixtures which do not react chemically but physically mixed together in any proportion. Whatever proportion you want, you can mix it and that will be mixed, and no need to use any chemical processes. Just physical method is enough to mix glucose powder in water. Do we need to go with any chemical processes like distillation or chromatography? No. Just take a beaker, add some amount of water, add 1 spoon of glucose, stir it, you will get glucose water. It is very simple process. And mixtures again divided into two categories. Most important, homogeneous mixture and heterogeneous mixture. It is quite easy to understand what is homogeneous and what is heterogeneous. You see, all the components of the mixture are uniformly mixed. While coming to heterogeneous, all the components of the mixture are not thoroughly mixed. If you find proper mixing, it is called homogeneous. If you find improper mixing, that is known as heterogeneous. Example, sugar dissolved in water. You take beaker, add some amount of water, add sugar in it. If you stir, total water in which sugar will be dissolved without leaving any traces, without leaving any sediments. And while coming to heterogeneous, take one beaker, add some amount of water, add some amount of sand in it. And if you add sand, you can observe all those sand particles will be settled down. And you can take example of sand and common salt. Take one china dish or plate, you can take, add 1 spoon of salt and 1 spoon of sand. you can find when sand and salt both are mixing together, you can find different colors. White color will be for salt and some brown color will be for sand. So both will be different. Those are heterogeneous mixtures. Number 2, no separation boundary is visible. If you mix lemon juice in water, that lemon juice will be completely mixed in water and there will be no boundaries. You cannot find any boundaries, you cannot find any layers. But while coming here, separation boundaries are visible. Easily those separation boundaries are visible and we can divide it, we can separate it also. And it consists of single phase. There will be only single solution. There will be no sediments, no extra particles, no extra molecules, no extra layers. But while coming to heterogeneous, it consists of 2 or more phases. Let us take water and add oil. If you mix water and oil, you can see separation boundary, isn't it? You take beaker, consider this is water, and you can add oil to it. So oil will be floating on water. Exactly here you can observe separation boundary. And it consists of 2 or more phases. Water phase you can find, oil phase you can find, like that you can find different phases. That is about homogeneous and heterogeneous. If solutions are completely mixed, thoroughly mixed, properly mixed, that is homogeneous. If it is not properly mixed, if it is not thoroughly mixed, that is heterogeneous. And we have difference table between mixtures and compounds. Let us try to understand these mixtures and compounds. First, what is meant by mixture? Various elements just mix together to form a mixture and no new compound is formed. Mixture in the sense we will add, consider X is one type of particles, molecules, and Y is another type. We both will mix together, we will get XY substance, that is called mixture. And compounds, elements react to form new compounds. Here oxygen plus oxygen plus oxygen will form together to get ozone. Oxygen is different, ozone is different. You see hydrogen plus oxygen, hydrogen is a gas, oxygen is a gas, but we will get H2O molecule compound, that is water. It is in liquid state, right? Always new substance is formed, new compounds. Mixture has a variable composition, different proportions, different compositions will be there, but while coming to compound, it has fixed composition. Whenever we get water molecule, definitely hydrogen and oxygen should be mixed in the ratio of 2:1. There is no other proportion to get water molecule, but while coming to mixture, it's your wish to make your own composition. Whatever it may be the ratio that will be mixed. If you want sugar solution, you can take 100 ml of water and you can add 50 grams of sugar. Someone can add 100 ml of water and 60 grams of sugar. Some may add 50 ml of water, 10 grams of sugar. That proportion is not defined. Third one, a mixture shows the property of its constituents. Whenever there is a mixture, different properties will be there. For example, if we add salt plus iron powder, salt plus iron, if you mix together, salt will have its own property, iron will have its own property. Now take that mixture of salt and iron, dissolve in it water. What will happen? Total salt will be dissolved in water and iron will be settled at the bottom. And now take that salt and iron substance mixture, take one magnet and roll it. Total iron will be stick to the magnet, it will be attached to the magnet, but not salt. So salt will have its own property, iron will have its own property. But while coming to compound, Compounds properties are totally different from its constituents. If we take water, water has its own property. Apart from that, water will not have separate property of hydrogen, separate property of oxygen. If we take zinc oxide will not have separate property of zinc and will not have separate property of oxygen. Zinc oxide is different like that. And mixtures, they do not have fixed melting point, boiling points, etc. There is no fixed boiling point, there is no fixed melting points, nothing. But here there will be fixed melting points, there will be fixed boiling points. And last point, the constituents can be separated easily by physical methods. I told you, if you take salt and iron, you can easily separate salt and you can easily separate iron. But while coming to compounds, it is not that much easy to separate it, and constituents can be only separated by chemical processes, not by physical processes. Mixtures can be separated by physical methods, compounds will be separated by chemical methods. Those are concepts of mixtures, compounds, homogeneous, heterogeneous, pure substance, impure substance, metals, non-metals and metalloids. Guys, this is introduction video of your chapter Is Matter Around Us Pure, and you will get these videos in English at the same time Telugu bilingual. I'll upload this video in English and Telugu bilingual. If you want, you can watch that video too. And in our next video, let us see continuation topic of this chapter, and in our next video we are going to see about solutions and different types of solutions. Guys, if you like this video and if you find this video is informative, you can share this video to your friends. Subscribe for this channel, you will get more and more videos, and you will get complete lectures of all chapters in your grade 9. Thank you, and we'll meet in our next video.